All right, good morning, everyone. We're going to start in 1 minute.
Daniel, I guess I could go downstairs and get my suit coat. It's work coat. Doggone you.
Yeah, we didn't do the dress code memo, I guess. All right, why don't we go ahead now? Good morning, everyone. Welcome to the April session of our QIF Coffee Chats from DMSC. My name is Mark Thomas. I'm Executive Director at DMSC, and today's session is going to be all about QIF 101. We have our two presenters. We have Mr. Curtis Brown from Honeywell, and we have Mr. Daniel Campbell from CUPID. Both of them are subject matter experts on QIF, and hopefully are going to give you an informative session today. Curtis, if you could go to the next slide, the housekeeping slide. All right, so basically we're going to have our session first. All throughout the session, you will be able to ask questions by typing them into the control panel on the right-hand side. You'll see one of those drop downs selections is questions. You can click on that, type in your questions, and those will collect throughout the session. And at the end of the session, we'll go through all of those particular questions and hopefully get you the answers you're looking for. Also, you should know that we're going to be sending out, and this is an automatic thing, so you'll be getting a video copy of this presentation tomorrow afternoon. And so that will be yours, and we very much encourage you to share that with your colleagues that weren't able to make this session. So I guess that is it. Curtis, go ahead and go to the next slide, and you're off. Thank you.
All right, well, I want to echo Mark and welcome everybody to a brief session on what the QIF is all about. Very thankful that I have Daniel Campbell here available as a panelist that will provide some expertise as well. So before I get going, a quick introduction about myself, but I also want to thank that this presentation has been modified since we kind of showed this maybe 2 years ago, and I'm thankful of all those that contributed to this as we add to this baseline of what is QIF, what is the DMSC, and so I want to thank you for all the past authors on this, and as we continue to grow on the content of this presentation. So this is a little bit about me, Principal Mechanical Engineer at Federal Manufacturing Technology, which is part of Honeywell. I'm all about going model-based enterprise, and my favorite quote is, I want to attain trusted models, manage them for confident reuse throughout all product lifecycle activities, and of course my first love is quality. So we're going to start off and talk a little bit about what is the DMSC. And our mission is to provide standardized interoperable data framework for manufacturing. We do that by creating these quality-related standards. And the intent is to affect the digital thread for the benefit of quality or metrology in a manufacturing environment. A little bit more about who the DMSC is. It originally started as being called Dimensional Metrology Standards Consortium. It's a nonprofit consortium organization. It's sponsored by organizations, whether that's individuals or as a small company, or small, medium, large, or academia or government organizations. It was conceived back in 1983. It became a separate legal entity in 2005. And then just recently in 2018, we changed our names as being Digital Metrology Standards Consortium based on our focus. And so, as I mentioned before, we foster and encourage the development of interoperable standards that to the benefit of our community, which is the digital metrology community. And we believe that these standards will provide significant impact as we go model-based and specifically for the quality enterprise within production. The group, and we're growing, consists of a host of manufacturing metrologists, software developers, and innovators worldwide. And a couple of years ago, we added up our experience and came up to over 500 years of experiences that contributed to the QIF. Many of you may know or remember the Dimensional Measuring Interface Standard. It's still an active standard, so we're maintain that, as well as being the developers and maintainers of the QIF, the Quality Information Framework Standard. As you know, we're an ANSI accredited standards development organization. We have a liaison relationship with the ISO TC184 SC4 folks, who are also the same group that produces the STEP standards that we fondly acknowledge. And they have harvested our standard, the ANSI DMSC, as being an ISO standard, and we'll talk about that in a moment. Also, the DMSC charters working groups, and so many of you may be interested in a working group as we are actively enhancing either the existing standards that we have or possibly creating some new standards. So a little bit about our pedigree and where we came from. And this is kind of looking back with the future in mind. And so back in 1986, the first version of DMS, the Dimensional Measuring Interface Standard, came out. And it continued to evolve even as we changed our name to become the Dimensional Metrology Standards Consortium as our own separate entity. And you can notice that about 2011 is when we started working on a QIF standard. And so the first accepted ANSI standard for the QIF was in 2013. And then you can see the pedigree there as we went to QIF 2, 2.1. Then we had a modification to DMS so that it could incorporate some significant things out of the QIF. Notice we changed our name in 2018, which produced this QIF version 3.0, and that QIF 3.0 became accepted as an ISO standard 23952. By the way, the DMS standard is also an ISO standard. It's 22093. So this leads to our first poll question. So we want to get things going. The question is, what QIF version are you primarily using or planning to use? QIF 3.0, QIF 2.1, maybe a QIF before 2.1, a future QIF version, or none, or to be determined. So we'll get let another 30 seconds go. So obviously QIF 3.0 is our current standard, and it's also the ISO standard as well. All right, I'm going to give it another 5 seconds. And we will close it. Looks like we're through. I'm going to go ahead and share the results. Hopefully you're seeing the results. So looks like most of those are 56% says none or to be determined. We have a good selection that's working on the current version, which is QIF 3.0. All right, well, thank you for sharing that. All right, I'm hoping I'm back to the presentation. So as we start looking forward, we're going to finish up with that history of the DMSC, and now let's look forward to the future. And the future currently consists of multiple working groups. Two recently new ones consist of model-based characteristics, and there's another one called non-contact metrology. And the model-based characteristic working group is defining, taking advantage of, okay, what is a product characteristic that the QIF kind of introduced? The QIF talked about tagging your product characteristics. We called them just characteristics back then. And so let's describe those a little bit better. Let's see what they might look like, human readable, and also as persistent identifiers and maybe at a machine readable format. And then we investigated or are investigating characteristic with optional augmentations such as criticalities that you might have, such as safety, or also maybe you have some type of product requirement association that might justify a product characteristic, knowing a product characteristic is associated with a annotation or a spec or a tolerance that needs to be verified by a quality person. And then we also identified some augmentations that will identify maybe the quality plan requirement that might be associated with a product characteristic. So in the picture there shows a flatness callout that has a human readable tag, a PC002. You could also call them 15 or whatever numbering scheme you might have. The symbology is kind of shown below that, where maybe in front you have a mechanical requirement number 52 that helps justify PC15, and then you might have a critical requirement with that type of labeling nomenclature. The other group is the non-contact contact metrology group. We're thankful to our Japanese friends who have identified additional non-contact metrology measurement resources, and that group is actively identifying additional resources on how non-contact measurement workflows using the QIF as the foundation and describing how that might be. So they're busy working on those as well. So you might query us about participating in those working groups. So let's talk about what is the QIF. And it starts off with, okay, why? Why start with why a QIF? Well, the world needs a standard for digital metrology. We've heard from manufacturers and their suppliers that they want common interfaces, interoperability, persistent traceability throughout the design to manufacturing processes, and a way to communicate those results. So how could we do that? Well, we envision that with through some standardizations, and you already seen where we created an ANSI standard with the DMSC work that's been harvested as an ISO standard. This describes a neutral digital file format that requires minimum software development and is enabled by the XML schema. And the WAT is, is 3D digital metrology data that is persistent, is traceable, and we want it to be trusted. So a little bit more information about the QIF standard. Mentioned the two different forms, which are basically QIF version 3.0. It's an integrated model for many elements of manufacturing quality information. The standard helps define, constrains, and exchanges model-based definition, which includes features in the metrology measurement view. We have semantic PMI, which are often called characteristics. There's a quality plan application that helps define the what needs to be measured, or a bill of characteristics. And then you can add and complement the what's with the hows. And once you identify how you're going to verify the what's, then we call that an inspection plan. So that includes those methods of how to inspect the what's. We acknowledge that the measurement execution is through our DMSC 5.3, which adds some QIF enablers, such as the CUPIDs that I'll talk about later. And then, of course, many of us know that QIF can have measurement results for individual piece parts, and then we can have a statistical view of that as well. One of the main things that we think is a key advantage for traceability and the digital thread is the active use of these QIF Quality Persistent IDs, or CUPIDs. And basically they're a UUID or a GUIDs, as Microsoft calls them. And so as you can see, it's a CUPID follows the UUID standard, which is 32 characters. And so it's guaranteed to be universally unique. And I have a couple slides that addresses that later. So a little bit more on what the QIF is. It's a feature-based, characteristic-centered ontology of manufacturing quality metadata. Well, ontology is just the science of how information is described, how they're related to each other, what properties and relations they might have. And so our XML schema captures all that, which leads to the next graphic there. It's based on XML. It's XML. Anybody that's in ComSci will understand what XML is. You can implement it with lots of available codes, and it does allow you to build in some code validation. And then, of course, we want to understand how these are all semantically connected, and specifically how it's connected to the model-based definition. And so this allows us, with the persistent IDs, ability to connect all of our features, our characteristics, and a lot of other quality information back to the model. And then, of course, we know that it's been realized not only with ANSI, but with ISO. So the QIF 3.0 has been approved as a digital interoperability standard, both with ANSI, and now it's been harvested with the ISO 23952. So we're very pleased with that, and anxious to, and many are taking advantage of that. A little bit more on identifying some of the application areas. This is our, some people call it the donut, I call it lifesaver. In the middle is some reuse libraries that we would reuse for all the different applications. So that contributes to interoperability within these applications. So the two libraries mentioned there is the features library and the characteristics library. But as we walk around the lifesaver or the donut, we see different applications. And so there is a QIF model-based definition, which provides the CAD, the shape, the PMI, and the feature information. You know, it's not required for all QIF use cases, but if your use case includes the model-based definition that has that PMI, then we're very well connected. Next is QIF plans. This gives you a wide range of optional levels of your planning. Maybe at a minimum, you just define what you want to measure. People call that the bill of characteristics. And then as you add additional information on how you might want to measure, that becomes part of your inspection plan. You can also assign measurement resources to them, and then maybe you can designate, maybe based on rules or whatever, your sampling point scheme. The next application is on QIF resources. This is where you can help define available measurement equipment that you might want to consider in your plan. And so we feel like we've got a good representation set of quality measurement devices, and includes information that helps describe those that we could use. The next group is the fact that we understand that we want to maybe start capturing quality measurement rules. And so we created a template for you to capture your company or your organization's rules. Those rules could be help you define how you might want to measure something, or maybe selection of what measurement resource you might want to use. And so consider investigating these templates as a common way to exchange your rules for measurement. The next one is considered the DMS. It's actually not part of the QIF. It's its own ANSI and ISO standard. However, DMS 5.3 has been updated to harmonize with some of the data traceability mechanisms that we see in the QIF. The next group or application is results. And this is our foundation. We wanted to have a better way of representing our measurement results. And of course, these results can be related to your model-based definition. And they can be associated with whatever points or devices that you use. And of course, they are associated with the features that you describe, and of course, with your characteristics. And the last application deals with the statistics. And that's how we can bundle all these QIF results together and perform some statistical analysis on those. And you can optionally include the results of the statistical analysis as well. So that kind of completes our current application areas around the QIF library. Another view of the QIF is how it enables the quality digital thread. If you open up and look at the schema, the QIF fits into something called the QIF document. And as you add more information, it gets added to this QIF document. So, for instance, if you add QIF MBD information, it gets added for your specific model-based definition. It gets added to this QIF document, which is our digital thread. And then as you start pulling out information from the MBD, you'll create your QIF plans, and then those plans get put back into the digital thread. And then as you pull in and investigate and select different QIF resources, those get added to the digital thread. You may want to consider some certain rules, so maybe you pull in a rule for different applications. So those get added to the quality digital thread. Then, of course, based on your inspection plan, you go out and execute that, maintain that persistent CUPID that we talked about, get those execution results from via DMS 5.3 or other devices, and then export those measurement results in the QIF results format, which continues to get added to the quality digital thread. And then if you want to conduct your own statistical analysis based on data that's in the digital thread, add your content statistically and put those back into the thread that consists of your full digital thread results. So plan, do, check, act. All right, a couple QIF workflows. This is an example of how we might take advantage of that digital thread. Maybe we'll first start off with, we have some type of model-based definition of the part that we are measuring. It has annotations on there that we want to identify measurement tasks or bill of characteristics. And so based on that, we'll create our own QIF bill plans as part of the bill of characteristics. So that gets added to that digital thread. Then stage 2 is we'll assign measurement resources to that based on maybe some QIF rules. And then we'll add to that QIF plan, which was just a bill of characteristics. Now it gets turned into an inspection plan. And then that gets added to that digital thread. And then we can create inspection programs based upon the inspection plan. In this case, the DMS standard would be applicable. And then we would execute that DMS part program on one or many serial numbers of my particular part and realize some results. And so we will calculate those results from the execution. And then, of course, we need to analyze those results and see what's going on with a lot of parts or individual serial numbers of those parts. So that's kind of a good example of our workflow, different 5 stages here. And then, of course, that can all be connected and associated or semantically linked through those persistent IDs that we talked about and to your authoritative model. And so that kind of fulfills traceability requirements, provides opportunities for additional data mining based on all this information. Two things that you've already heard me talk about, and I just want to talk about them a little bit more. These are fundamental constructs for the basis of our QIF, and those are features and characteristics. And as you look at your geometry of your model, we want to convert those geometries in something a little bit more simpler to use, and those are features. And so the QIF, thanks to DMSC and other works, identifies many different feature types. Now, these are different than design features that your CAD systems would have, but these are features for us as quality manufacturing quality individuals. Sometimes they're called measurement features or metrology features, but those are described here in the QIF. And then, of course, those features are specified by characteristics. Some people call those product characteristics or inspection requirements. We may know those characteristics as being geometric tolerances, such as flatness or perpendicularity, or they could be dimensional tolerances like diameter or width. And then they could be other specifications like surface finish or some notes that you need to verify. And of course, the QIF acknowledges that certain features may participate as a datum feature to support another geometric characteristic, like perpendicularity example. So the QIF controls and understands and able to exchange all this type of information. So one slide on the on CUPID. Actually, I'm going to have a couple. We fondly call this, it's a QIF persistent identifier, but we fondly call it the CUPID. But it's just taking advantage of an ISO standard already there, which is the UUID. I mentioned before, Microsoft calls them the global unique identifiers. But the QIF has sprinkled CUPIDs in unique and important areas. The QIF document will have one. The features could optionally have those. A measurement resource could have them. And I bolded characteristic items. I think that is one of the critical persistent ID opportunities for us, because we believe that's the most important mechanism to help connect all life cycle activity with that particular item. So I think we got a quick example of maybe what a CUPID and how it might be used in your QIF document. Obviously, your overall document could have this UUID so that it would be unique. And then, there's opportunities to identify your shape feature or the features. In this case, we have a complex surface that internal to the QIF file, there is an ID. In this case, it's 3178, and it will be unique within that file. But if it's important for you to have a universal unique ID, you can optionally add a unique persistent UUID to that same surface feature as well. Likewise, any characteristic within the QIF, you'll have a unique ID within that part file. But if you need to give that QIF out and maybe maintain that CUPID for other use cases and bring it back together, you can optionally identify that same characteristic with a UID as well. I sometimes kind of think this as, yeah, you can call me Curtis Brown, that's my human readable name or tag, but to the United States government, I got my social security number, and that's what they call me, and that's my unique identifier, persistent. And so that's kind of the same here. All right, so let's look at how we're impacting the digital thread with quality. First of all, we have a lot of questions about how we're supporting all the different GDT standards. And you know, when you kind of analyze them, they're all pretty much very at the level that the QIF needs to describe them. They are all basically pretty much the same. Yes, we first started off with the ASME standards. We've done a lot of mapping and comparison with the ISO GPS family of standards, and compare that specifically as we went ISO. So we spent a lot of time comparing and added a few new needs that was identified in the ISO GPS standards. And then, of course, with our JADA group, our Japanese friends have taken advantage of maybe kind of more a general view of geometric tolerancing, and we've accommodated those as well. So we feel very confident that no matter what tolerance, GD&T tolerancing scheme your approach is, the QIF can address that. If not, we want to hear about it, and we will change it so that it will accommodate those standards. One little additional thing on the model-based characteristic working group. Mentioned before, the working group is working on how we would tag as a human readable tag on your models or even your drawings, and they're looking into different augmentations as described before, but they're also adding that all-important persistent universal unique ID. And we figure that the earliest you can identify those, the quicker you can provide feedback back. And we could actually maybe in the future associate, once you add those universal unique IDs to everybody, then you can bring all that inspection data back, and maybe based on those universal unique IDs, you can visualize what those results are back into where those persistent UIDs are appearing at. So the QIF with these persistent product characteristics helps them enable measurement results to be traced back to the model. Super excited about that. Well, we believe QIF provides a lot of business value, not only to the manufacturer user's perspective, but to the vendor's perspective as well. And from the user or manufacturing perspective, we all want a common information interface. We want freedom of choice to select best in value based on the metrology solutions available to me. And also give me an opportunity to have interoperability between all those best in class, best in value hybrid solutions. We like to have one standard format for measurement results. We want persistent traceability between disciplines and then back to the model. And we want to be able to communicate inspection results back to design and back to manufacturing. We feel like that this impacts model-based enterprise progression or your maturity to become a Industry 4.0 or a model-based enterprise or a digital enterprise. This will impact quality, and maybe they could be the primary driver for you to go model-based. And then we like to have a common format to capture these features, this PMI, and then, of course, have the model-based definition through features in PMI linked with our quality results. And, of course, having it as an ANSI recognized standard, and better yet, an ISO standard, that's what we would like to have. And that's what I think we have. And then in the vendor's perspective, we want to be able to reduce cost. We want to concentrate on our core competency, not try to fit everybody's solutions, and therefore the QIF can contribute to that. We want to be able to have a way to inherently validate the data is correct. Using XML schema-based implementation makes that is an enabler for that and makes it easier. We believe it's more cost-effective to do it this way. XML can be extensible, so your QIF, and then maybe you want to extend it a little bit based on your particular needs. This could expand your market opportunities where you could maybe penetrate more proprietary systems. And then one standard format for them all for measurement results. And again, a common format, links to your model-based definition with your quality information. And again, like to have a recognized standard, and better yet, if it's an ISO standard, is even better. So now let's start our next poll. And this is a poll that we did 2 years ago, so I'll be anxious to see what our results are this time. So what is your organization's current level of QIF maturity? Is it none? Are you still investigating? Or has that investigating got to actual planning? Are you implementing, or have you adopted or adopting? So I'm getting 70% of the vote in so far after 30 seconds. I have 80% of the vote in. All right, well, it looks like we got the votes in. I will close the poll. I will share the results. Looks like we have 40% are investigating, and 22% is implementing. Last time we actually had 40% investigating and 15% implementing. So we've increased our implementation, and we've increased our adoption levels as well. So looks like we're making progress. So thank you for participating in that poll. I'm hoping I'm back to the presentation. And now we're going to look at a few more detailed workflows. I'm going to speed up my discussion. Many of you have already seen this slide, but this is kind of the product acceptance activity workflow, where we start with some type of design of your product that produces your product definition with PMI. Then you determine your measurement requirements that defines your measurement scope, often called your watts, your bill of characteristics. And then you look at your measurement resources, and based on your metrology knowledge, you define your measurement process or inspection plan, so that matches the hows to the watts. Then you actually execute your measurement process. You might have coordinate measurement machine or other measurement devices, but they all produce results. These results need to be analyzed and reported and sent back to the enterprise. And so as we look at the standards available to us, early on we had the DMSC standard that accommodated one information exchange from one activity to another, and then there was an I++ DME that was provided to talk to your measurement resource. But with the introduction of the QIF, introduced QIF plans and results, and those provided standard ways of information to be exchanged from those activities. QIF 2.0 was a watershed where we added a significantly new number of applications like the QIF MBD, QIF resources, QIF rules and statistics. And then QIF 2.1 added content to that to be more traceable. That's probably where some of the CUPID showed up. And then the 3.0 added enhancements and extensions to that. So as you can see, all the major information flows from activity to activity is satisfied by the QIF. Now let's look at a couple use cases. Maybe I'm an OEM and I'm interacting with my suppliers. And in this particular case, I'm going to create an inspection data package that I would include the model. I would include what I want to be measured, and then I would include the QIF rules. And then you let the supplier apply those rules against your list of what needs to be inspected on your model, and then they would create their own QIF plans and create results. So that's one scenario. Another scenario might be that your OEM would not only add your bill of characteristics, but it would apply its own rules and create its own inspection plans. Maybe they understand the supplier very well and know its resources. And so in that inspection data package would include the plans for inspection as well. And then you ask your supplier to perform that inspection and provide you with results. Another use case is maybe it's all in-house fabrication, where you produce those and control those yourself. You have your own internal fabrication and verification. So those are just a couple examples of some use cases. So let's wrap this up and get to some questions. How are we impacting the digital thread with quality? Well, the QIF is a global standard. It defines a structured format that helps communicate and preserves this information, and we believe it helps enable manufacturing automation. It is a standard for machine-to-machine connection as well that could connect different vendors of quality suppliers. We believe it helps impact the creation and definition of the digital thread. We believe the DMSC is the driver for the standard as we're looking at contributing or creating new standards through these two new working groups, as well as we're working with other standards organizations to harmonize their standards with the QIF and vice versa. This is our current membership list. It's is definitely growing, so we appreciate our members. And we have general members meetings twice a month, or monthly, I mean. This is our board of directors. Many of those you'll recognize. Luckily, I have Daniel Campbell to help me answer some questions later on. And then I want to just make sure you are aware of the resources. We are on the web. Obviously, you can go to QIFstandards.org. In there, there's a place that you can find different resources. You can find past tutorials and other information. You can also download the QIF, the ANSI version of QIF we can download. If you want the ISO version, you need to go to the ISO community to obtain it that way. And then for those that are more interested in more details and maybe apply the QIF, there's a GitHub. And so that's through qualityinformationframework.github.io. So lots of good information, some source code bindings, the QIF schema browsers there, some example instance files, and some getting started videos. So let's do our very last poll. And that poll is going to be, what should the DMSC do next? And this will help us a little bit. So I'd like to hear from you. Should the DMSC create a QIF Wikipedia info page? Should we extend the QIF with new measurement resources that have been talked about a little bit? Should the QIF be extended with additional product characteristic capabilities? Should the QIF get registered as a NARA, National Archive approved format? Or should the DMSC provide a QIF viewer? So this is a little bit harder question, but like to hear from you. We as attendance to this coffee chat. Got about 50% of the votes in. I know many would like to vote for more than one. I would. All right, I'm just going to give it another 5 seconds. Looks like we got our votes in. All right, so I'm going to share the results. Looks like the number one is provide a QIF MBD viewer. Then number two is extend the QIF with additional product characteristic capabilities. And looks like we got a tie for the others. All right, thank you for sharing that. Let's finish up this. road, this chat, with a request we have for you. We would like for you to spread the news about the QIF. If you're not a member of the DMSC, we'd love to have you and get your contributions. And then, of course, go out and download the QIF. And so there's opportunities for you to get some information about the value of being a DMSC member. There's different membership levels that you can join at. And then our next DMSC membership meeting is April 21st, coming up fairly quick here. So with that, we are going to open it up with some reviewing some of the questions. Either myself or Daniel or Mark will look at some of the questions and we'll attempt to ask some of those. So Daniel, are you online with me and ready to help pick some questions to address? All right, I am working this, not very good. Daniel, are you there? Can't hear you.
I was muted. I am here.
There you go. Great. I am going to have to reorganize. I cannot read all the questions right now, but I'm going to work on that. Do you have one that you want to bring up and ask or share?
Mark, are you? I don't have visibility on the questions, actually.
Okay.
Mark, are you there? Were you able to go through some of these questions?
Yes, okay, I'm going to read these questions here as they're coming up. So first question is QIF 3.0 references ASME Y14.5M 1994 and Y14.5 2009. Why not the latest revision Y14.5 2018?
Well, our QIF 3.0 was created in 2018 as well. So I guess we thought it was too new or we didn't have that available to us. But, you know, the next version of QIF will need to address 2018 and might require us to make some minor changes based on that. Daniel, have any additional comment on that?
Yeah, I think that's right. It's just the timing. It was just the timing that they were coming out basically at the same time, being finalized at the same time. Even though the QIF is ISO 23952 2020, it was ISO in 2020, but this version of QIF was actually released before the release of Y14.5 2018.
Right.
I would say that there are very, very minimal changes that affect QIF. I think dynamic profile is the biggest one. Yeah.
All right, so the next question is, does the measurement execution have to use DMS 5.3? What if the metrology software being used to drive a CMM does not support DMS 5.3?
Yeah, I would say it's a good question. I mean, the DMS being in that that pie chart or that sort of that graphic there is simply to highlight the fact that DMS does coexist with QIF. It's been harmonized to fit with QIF, but by no means is that necessary. In fact, yeah, there are a large number of different metrology software tools out there that support QIF and you know, work with QIF totally outside of the DMS world.
Yeah, I would think maybe at a minimum, if you want to have all that traceability and provenance that the QIF offers, that you try to maintain those persistent identifiers that we described and we call CUPIDs. And so if your favorite CMM execution software or planning software can maintain that, then you meet a primary need for maintaining the digital thread. Over. Mark, I'm not able to see any other question. I was only able to see the first question, so you might have to share if there's any others.
All right, so next question is, and there's a term here I'm not familiar with, but it says, has there been any consideration towards using JSON schemas and JSON,
JSON.
JSON?
Yeah. No, we have not. We haven't gotten into that with QIF. We've stuck to XML. The data that's being characterized by QIF and I guess the schemas that are designed or that make up what QIF is are pretty heavy. So in certain ways, they're kind of more suited towards XML and XSD than they are for JSON. But I think that, yeah, I mean, that could be in the future a potential.
Yeah, and Daniel's exactly right. However, we are, for the whatever next version of QIF comes around, we did put a line item to investigate other schemes or newer technologies or what have you. So we're at least going to understand that question better and hopefully make the best decision.
All right, so the next question. Oh, yeah, well, I was going to cover this right at the end, but it says, will this slide deck be made available? And I'll go ahead and answer that because the answer is yes. This slide deck will be available. It will be put on our website and it will be under the resources tab. And it will probably take a day or two to get there, but we'll certainly be putting the slide deck and the presentation on our websites under resources. All right, so the next question is, why can't we use QIF in lieu of ISO 10303-242?
Well, maybe you could. We have done a lot of comparisons. It is interesting that the ISO community that did create AP 242 has harvested QIF, which included the MBD. And so, you know, we believe there's use cases for both. But if your use case is more directed to accepting product and maybe look at the, you know, how well we've semantically represented characteristics, and of course we have features dedicated to the metrology use case, then maybe the QIF MBD would be a good choice. But we do know that ISO AP 203 and 242 is, you know, more predominant out there in uses. Daniel, you want to delicately address that as well?
It just depends on the use case. I think that they're both strong MBD formats with kind of slightly different scope. And I know as I think some of the people have pointed out here in some of the questions and comments that came in, there's been a lot of harmonization between QIF and Step 242, and then actually other data standards like MT Connect. You know, sort of harmonization of, you have different data that comes from different silos, different groups, and you want to try to harmonize them to, you know, weave a single digital thread across your enterprise. And so, you know, QIF often is very dominant in the quality area, Step 242 in the design engineering area, CAD interoperability area, and then flowing into machining as well, and then MT Connect obviously for telemetry data from machine tools. And there are important efforts going on tying all of this data together using UUIDs and universal IDs for tracking common data points between each of these different data sets. So yeah, I think they all just have their own, you know, their own place from their own domain.
All right, very good, thank you. Next question is, how does DMSC impact PC DMIS, or does it?
DMSC, so QIF with PCDMS. I mean, I would suggest reaching out to Hexagon, the vendors and developers of the PCDMS software, and they could talk to you about QIF. But they are they're implementing. They have an implementation for QIF and they work with it. But I would recommend reaching out to your Hexagon rep and asking them for the details on that.
Okay, next thing. Are different software all able to read the QIF documents?
Yeah, I mean, that's the idea, I guess I would say. That's the purpose, is that you might have this one software in one area that excels at some task, another software in another area that excels at some task, and then finally you have your product definition, and let's say Creo or NX or CATIA, and you want to use that to drive all your operations. So in general, the point is you have these different softwares in different domains, and you want them to communicate with each other. And that is, I mean, there are a number of workflows that evidence this, and there are a lot of organizations out there that are taking advantage of the QIF to do just that.
All right. Next question is there any error checking for the characteristic requirements? Bad GD&T requirements need to be caught early in the process, and it does no good to pass this further down line.
Well, the QIF does have some checks. It's not going to give you a grade or tell you that it was. I mean, there are some checks that may prevent you to doing something kind of silly, but it's not going to be a GD&T analyzer or checker. But it will validate that it is semantically connected or makes good sense connection-wise. Danny, you probably should address this better than me.
No, I think that's right. I mean, in general, also, I think it's important to remember that, I mean, QIF is a data format. And then you have software tools that do some of the tasks that, one might think of in terms of, create a CMM program, run the CMM, evaluate the results, create the product definition, do translation, things like this. And one of those things might be checking GD&T for semantic PMI correctness, checking GD&T to make sure that it conforms to Y14.5 or ISO GPS, or to certain best practices you might have. So some of these things might be software tasks that are enabled by the existence of a strong data format like QIF. And there are definitely software tools out there for doing checking on GD&T and stuff like that. So.
But the QIF will, based on the schema, it will adhere to that schema. So the quality of the schema and the checks that compares it to the schema will provide those type of checks. But you still need other, like Daniel said, it is a data exchange format, and it's not really going to grade what you got or whether you have a complete definition. But per the schema is going to validate that it's correct to the schema. And so there is limited checks within the schema to make sure you're doing some things correctly. Over.
That is true. Yes, absolutely. Yep. All right. So we have time for just one more question here. It's let's see. Is there any sort of configuration management, things like identifiers, structuring, etc.?
So I guess my initial answer on that, Curtis, I'd be curious what you say, is that the QIF is not, it's definitely designed to live in the world of product lifecycle management, software. So for QIF, just like you might with native CAD files or something like that, you would want to manage it with a system that can do things like configuration management and so forth. And it is a very highly structured data format, so it's suited very well for that type of management. Yeah, I don't know, Curtis, what would you think?
Yeah, I mean, I agree with that. I mean, it's a file, right? So you can manage the file in any configuration management, a QIF file, add content to it, raise the issue, add more. But but that file, as we showed on that digital thread slide, contains more than just information on one application. It just grows and continues to that you can actually read that and pull it into other systems or other discipline systems that you need to have. So there's kind of two answers here. Yes, you can configure manage a QIF file just like you would anything else. But in our instance, the QIF file contains a lot of information, lots of different applications, and you can harvest that out or data mine that out to your heart's content, per what it contains. So hopefully we addressed that question adequately.
All right, so we're here at the top of the hour. I just wanted to thank everyone for their participation today. We do have these QIF coffee chats on a monthly basis. The subjects vary, so we hope that you will join us again. And as Curtis mentioned, we certainly invite you to join us at our monthly DMSC general membership meeting. It's a 1-hour meeting, and if you're interested, you can go to our website and look under events, and you'll see the link to go to that meeting. You do not have to be a DMSC member to join that meeting. So I do appreciate everyone's participation today, and we want to thank our presenters, Daniel and Curtis, for a good job. I'm sorry, by the way, if we didn't get to all your questions. We actually had quite a few questions here, and we could be going on for another half an hour perhaps. All right, everyone, thank you very much, and everyone have a great day. Thank you.
Thank you.